you'll see there's 30 exam questions in the actual paper. So the exam technique that I always share with the students is find 15 questions that you're comfortable with, sections that you're strong at, and start there. Do those questions first, and then you can always come back to the questions that are a bit longer or more difficult.
Okay.
Okay, so I'm gonna let's say that up front. So I'm just going to be taking you through question 1 all the way down to 30. But obviously, if I was actually doing this as a proper exam under exam conditions, I would be looking for 15 questions that I can do. The easy ones I would do immediately. I would get those correct and then move on and then come back to the other 16, the other 15, in order to get the distinction. Okay, so the priority is always to pass first and then focus on the actual distinction.
Okay, perfect.
Right, so just to mention that up front, always look for questions that you're comfortable with. It doesn't matter what subject. That's just general exam technique.
Yes.
The approach that I take when I
But like I told you, my brother looked at my third assignment and just went, good luck.
Okay. Yeah, you did mention that there were some tough ones in there because of the integration that. Okay. Alright, so let's start with May, June 2015. Obviously, you can see it's a 2-hour paper. It's out of 100 marks, and we've got different multiple choice questions covering different sections that you would have looked at over the course. Okay. UNISA would have sent you a study guide, and also there's a textbook, Essential Mathematics for Economics and Business. The 4th edition or 5th edition is what you would be using for this particular module. Okay, so the first question is question 1. When I read question 1, I'm always going to highlight, underline, circle things that stand out. So it gives me an indication of what they're trying to ask me in terms of working. So we've got a department here. A department store has advertised a discount of 35% on all items in the store. The price of a lady's blouse, including the discount, is 60 Rand. What is the original price? So we're obviously looking at now, and we're looking in the past. So currently the blouse costs 60 Rand. In the past, it cost more or less.
Obviously it was less.
It would have cost more in the past because now it's being sold with the
discount. Sorry.
Okay, so we're looking for that. What's the price in the past? Because the department store is currently advertising this item with a discount of 35%. So the original price is what we're looking for. So there's two things that we need to look at here. It's obviously the now, okay, the original price, and then the after the discount. So when approaching this question, I'm going to be giving the unknown a variable. So the original price is obviously going to be X. After the discount we know is 60 Rand. What happened from X to 60 Rand? We less 35%. That is what the question mentioned. So I'm trying to find the original price. I know what the current price is. I need to work backwards to get what the original price is. So to work that out, I'm going to have X minus 0.35X equals 60. I'm looking for the original price, which is X. So how do I work out X here? I need to simplify. So 1X minus 0.35 is 0.65X equals 60. Then X would then be equal to 60 divided by 0.65. X equals 60 divided by 0.65, 92 Rand 30, with 769 as a decimal there. Okay, so that's the working to get the first answer. The approach here was a word sum. I had something that I currently know in terms of what the current price is after the discount, and they're asking for the original price before the discount. So the answer must be bigger than 60. Do you agree? The price before the discount must be bigger than the price after, right?
Hello?
Do you agree? The
Yes,
price
I do.
before the discount must be greater than the price after.
I agree, yes.
Okay, so that's what we've got there. So any price here that's greater than 60 would be correct. They've given you different prices above 60. There's the answer, 92 Rand and 31, if I round off to 2 decimal places.
Okay.
Okay, so this question was a word sum looking at now and in the past. Obviously, we're looking for the original price, which was that, which is the x. I'm solving for x. That's what I'm trying to do.
Okay.
Okay. Question 2 is an equation question where you've got x and you've got an exponent. So we need to revise some of those key rules when looking at exponents. When I have an equation, I've got left-hand side must equal right-hand side. That's important from an equation point of view. Do these equations have the same terms?
What do you mean the same terms?
Do you have a base of 2 on both sides?
Yes, you do too.
No, you've got a base of 2 on the left. You don't have a base of 2 on the right. Okay, because remember with an exponent, you've got a base, you've got an exponent, and then you've got an answer. So 2 to the power 3 is 8. The base is the 2, the exponent is the 3. Is that okay?
Yeah, that makes sense.
Alright, so when looking at left-hand side and right-hand side, I need the same base. So I need a 2 for both of those sides. I've got 2 to the 5x plus 3 on the left. I need to convert 16 to 2 to the power something. 2 to the power what will give me 16?
3. Oh, 16, sorry. So it's 2 to the power 4.
Alright, so 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So we would have a 4 there. 2 to the power 4 would give you 16. Right, so now I've got a term on the left which has a base of 2, and I've got a term on the right which has a base of 2. Are those bases the same now? Yes, they are.
Yeah.
So if the bases are the same, must the exponents be the same?
No.
Yes, they do. They have to be equal, because what's on the left must be equal to what's on the right. Okay, it's like looking at a mirror. If you look at the mirror, you see a reflection, right?
Yes.
Okay, so imagine this as being the mirror here. The equal sign is the mirror. Okay, the mirror on the left is showing 2, so the mirror on the right needs to show 2 as well.
Okay.
So if I've got an exponent, this exponent here is a unknown, 5x plus 3. But the exponent on the right is 4, which is known. So are those exponents going to be equal? Yes. Okay,
no.
Here's a simple example. If I have 2 to the 3 equals 2 to the x, what is x going to be equal to?
3.
Yes. Okay, because what's on the left must be the same as what's on the right. So if I've got a 2 here and a 2 there, I'll have to have a 3 there and a 3 here. So x must be 3. Right, so in this question, all you had to do was equate that, the top bit, the exponents. Right, the exponents had to be the same because 5x plus 3 must be equal to 4. Does that make sense?
That makes sense.
Okay, so let's do that working. 5x plus 3 equals 4. Question 2, 5x plus 3 equals 4. Bracket exponents must be equal. So if I solve for x, these are basic, so just to revise a little bit of that, I'm obviously taking amounts to the left and the right. So I want to keep the x's on the left. So 5x equals, I'm going to take the 3 to the right. So it becomes a negative 3. I'm then left with x, or 5x, let's put more steps, equals 1. So x equals 1 over 5. 1 over 5 is the same as 0.20. Alright, you can use a calculator in the exam. you don't have to worry about doing mental math, okay? You've got a calculator. If you need to do a calculation on the calculator, that's fine. Right, obviously a fifth is the same as 0.20. So the answer for this one is going to be option 4.
4, yes. Okay.
Okay, question 3. Simplify the following expression. When I see something like this, I'm looking at BODMAS. Okay, so there's an order of operations, brackets of division, multiplication, addition, and subtraction. If I've got a whole bunch of terms like I do here, I need to apply BODMAS. So BODMAS says I need to first calculate the brackets, then any of, then division, and then multiplication before the addition and subtraction. It doesn't matter which of these two you do first. You can multiply first or divide first, it makes no difference. But the brackets have to be calculated first. So do I have a bracket there? Yes, I do.
Yes.
Okay, so I need to first solve the bracket before I can multiply or divide. So if I'm looking at that, how do I solve this? Well, I need a common denominator. So I'm going to write down a half there. Okay, I need to convert the mixed number into a improper fraction. So 6 times 2 is 12, plus 1 is 13. So 13 over 6 is the same as 2 and 1 over 6.
Okay, yes, that makes sense.
How do I simplify this? Common denominator. Common denominator would be 6. If I convert a half to 6, I need to times this by 3. So I need to times that by 3. So minus 3, then plus 13. Right, so what is the bracket going to give me as an answer? It's going to give me 10 over 6. That's what the bracket is as an answer.
Okay.
Okay, now I need to apply BODMAS. So I've done the bracket. There's no of here. Then I've got division and multiplication. So
sorry, what is of?
Of would be like 2. 2 of, or let's say a half of. A half of 10 would be what? 5.
Okay.
Okay, a half of 10 is 5. So of just means multiply. It's looking at a fraction of. Okay, so a half of 10 would be 5. A half of 4 would be 2.
Okay.
Okay, so of. There's no of here. Of would be just as it's written there. Of. Okay, half of.
Okay.
Of basically means multiply.
Okay.
Okay. Right, so I'm looking at the division and the multiplication. So here's division. I need to do that first. And then here's multiplication. I need to do that first before I can do the minus 2 plus. Okay, so this bit over there, I need to times because I can't use divide. Okay, so multiplication and division are opposites of each other. So I can swap this around. I can say 2 over 3 divided by 1 over 2 is the same as 2 over 3 times 2 over 1. Okay, you inverse the fraction when you change from division to multiplication. Right, so what does that give me? That gives me 2 times 2 is 4. 3 times 1 is 3. So that's that bit over there. Right, then I've got minus 2. Then I've got a half plus a half times this bracket. I know what the bracket is because I just worked it out. 10 over 6, right? Okay, so I need to multiply these two numbers out first because that's multiplication. Okay, so the next line will be 4 over 3 minus 2. What's a half times 10 over 6? Well, 1 times 10 is?
10 over 12, right?
10 over 12, yes. Okay, so now I've got 10 over 12. I'm going to add and subtract all of this. I need a common denominator, so put everything over 12. How do I convert 3 to 12? Times it by 4.
By 4.
Times it by 4. So 16. Okay, minus 2. This is 2 over 1. Okay, we don't write numbers over 1. we just write them as whole numbers, but there's an invisible 1 in the denominator. So if I to times it by 12, I'm going to get negative 24. Okay, and then plus 10. Right, so there's the common denominator. Common denominator of 12, I've taken that fraction and I've taken that whole number and I've converted it to a number over 12. All I need to do now is just add and subtract. Okay, so 16 plus 10 is 26. 26 minus 24 is 2 over 12. 2 over 12 is the same as 1 over 6. Is that okay?
Perfect, yes.
Okay, so the answer is it there? Yeah, it is. Option
Yes,
1.
number 1.
Right, so question 3's answer, BOD mass is applicable here. We need to first multiply out. After having done all of that, I then get 1 over 6, which is option 1.
Okay.
Great. Next, let's have a look at question 4. Alright, question 4 is a tricky one because they've given you all of these exponents and they've given you roots. Okay, so just to revise a bit of theory. When you see that sign, what does that sign mean?
Oh, I can't even remember.
Square root.
It's square root, yes.
Okay, so when I have a square root, what does that tell me to do? Well, it tells me to find two numbers, well, one number rather, multiplied by itself. Okay, it gives you an answer. So for example, if I give you 2 squared, what is that?
Isn't it 4?
2 squared is 4, right?
Okay.
If I square root 4, what do I get? 2.
Okay.
Okay, so square root means a number multiplied by itself to get an answer. Okay, so 2 squared is 4, root 4 is 2.
That's good. Okay, yes, got that.
Root 9 would be 3. Root 25 would be 5. Okay, why 5? Because 5 times 5 is 25. Okay, so that's what the root means. Right, when you see a number outside the root, in actual fact, we should put a 2 out here. Okay, but we don't write the 2. Okay, normally you do, but only for other numbers. So if I have that, then if I put, let's put 27 here. Okay, what does that mean? That means cube root 27. This means I need to take one number and I need to multiply by itself 3 times. So 3 times 3 times 3 is 27. Okay, so if I have a cube root 27 would be 3. Right, because 3 times 3 is 9, 9 times 3 is 27. Okay, so that's the answer for a term that looks like that. When you have a root sign with the number outside, it means cube root. Okay, if you don't have a number outside the bracket, there's an invisible 2 there, which means square root. Okay, another thing to revise here, if I have, let's talk about x to the minus 1. X to the minus 1 is the same as 1 over
1
x.
Okay.
Okay, that's the negative exponent. Okay, negative exponent means it's in the denominator. Okay, when you have negative exponents. Alright, so those are just some basics that that was covered in the study guide as well as the textbook. Okay, just to revise some of that. Okay, so when I look at this term, do I like how things look? No, I don't. Okay, I need to try get rid of some of the brackets and some of these negative exponents. Okay, so what am I going to do? I'm going to start by writing this in a better format. Okay, so let's write this in a better format. This would be the same as x, well, it's a minus 4, so I'll have y3 here over x to the 4. I've written this in a better format. That's the better format.
I just want to look at that. So y3 over x
Because x to the minus 4 means in the denominator.
But I thought you'd have 4 over x.
4 over x?
Yes.
4 over x. No, not 4 over x. We were just rewriting this bit over here as a fraction.
So if you didn't have y to the power of 3 and you just had x to the power of minus 4,
okay,
wouldn't you write it
x to the minus 4, then it would be 1 over x to the 4.
X minus 4 equals 1 over.
That's what I would have if I just had x to the minus 4.
Okay.
Okay, it doesn't matter what the minus is, it just means put it in the denominator.
Okay.
Okay. I just want to delete some of this. Okay. Alright, so if I'm looking at the next bit, this bracket bit, okay, let's rewrite the bracket bit better. Okay, so again we've got a y to the minus 4. So if the minus 4 is in the denominator, it's going to come back to the top in the numerator. Then you'll have 4x squared y 4. Right, now I've written that in a much better format that's more easy to deal with. Okay, is that alright so far?
You're perfect,
okay.
Yes.
Right, so now how do I get rid of these root signs? Okay, so earlier on I spoke about this. Okay, so how do I get rid of the root sign? Well, this would be the same as that. Okay, we know 3 to the 3 is 27. Okay, because 3 times 3 times 3 is 27. Okay, so cube root 27 would be the same as cube root 3 cubed. Right, so if I've got that, this root sign actually means the exponent divided by 3. Okay, so when you see all of that over here, that refers to this. Divide the exponent by 3. Okay, so if I have something like this, let's do the root 4. Okay, what is root 4? We know root 4 is 2. That's the answer. Okay, but how can I write that? If I write down all the steps, I'm actually writing this. Okay, so it's 2 to the 2 over 2, which is 2. That's what you're actually doing. That's the step-by-step process. Is that alright?
Yes.
Okay.
That's going to take a bit of time to
if I
take
have
in.
a number outside the root, whatever it is, it just means the exponent must be divided by that number.
Okay.
Okay, so let's do that here. I've got the 4 outside, so what am I going to do? I'm going to write down y to the 3 over 4 over x to the 4 over 4. Then I've got this square root here, so I'm going to have times by brackets. Okay, I will have, well, root 4 we know. What is root 4?
So 2 to the power of...
root 4 is just 2.
2, yeah. Okay,
so I'll
yes,
have
sorry.
2
Yeah.
there. Then I'll have x to the 2 over 2, y to the 4 over 2. Okay, so we need to simplify that. So I can simplify this. So this will be y 3 over 4 over x. Okay, the bracket is going to be 2x y squared. Make sense?
Yes.
Okay, so now what do? I need to multiply out. Okay, so I'm just going to write what I wrote down there again. Okay, over x times 2xy squared. Okay, so what must I do? Multiply out. So I can multiply the x with that and I can cancel. That cancels. Okay, when I multiply exponents, what do I do to the exponents? I add them. Okay, so what am I left with here? I'm left with 2y to the 3 over 4. Okay, which is the same as y, 2y. 4 times 2 is 8, 11 over 4. Okay, so I don't know which option they've given us in the question. Which one did they give you?
Sorry, can we just go back down? I just want to see.
Option
so it's
3.
2. Is it option 3?
Option 4. Yeah, 4. There's it.
Okay, so it's 2y, and then 2. Do you say multiply by, 3/4?
Well, 3/4, I'm adding the exponents, because x3 times x4 is what?
12.
X7. Okay, you add exponents when you're multiplying.
Oh, you're adding them. Okay.
Okay, you said 12. That's when I have this.
I thought you multiplied.
That's when you have this. That's x to the 8. An exponent raised by an exponent. Okay, when I have x to the 3 times x to the 4, I add the exponents. Because what does that mean? That means x times x times x times x times x times x times x. How many x's do I have? x7. Okay, so if you have a power raised by a power like this, then I'll have y to the 12. If I have y to the 3 times y to the 4, I get y to the 7. Okay, 2 different rules. Okay, the exponent rules are in the textbook as well. I'm just recapping them here as well, just because we needed it for the actual question. Okay, so when I multiply exponents, I add. When I raise an exponent by another exponent, I multiply. Okay.
Give me a minute. So I just want to quickly write this.
No problem.
Doing my calculation.
Yeah, these are just side notes. We actually finished the question. This is just a side note.
I always write everything out so I know exactly what I've done.
Okay, remember you'll have the video afterwards. I'm recording what's on screen, and I'm recording my voice. So the audio and what's on screen is being recorded. Okay, as a bonus after this, I'm gonna upload the video onto YouTube, and I'll assign your Gmail, Google account access to watch the video. Okay, YouTube will send you a direct link. If you just click on the link, you'll be able to watch what we did today.
Oh, okay, perfect. Okay,
yeah, so I am mindful that it's difficult to write and listen at the same time. So I'm recording what we're doing. You can watch it over and over again afterwards if you need to.
Okay, wonderful. Thanks. Okay.
Alright, so rather just try and understand what we're doing and ask questions about things that you're not too sure about. Okay,
that all makes sense.
Filling the gaps. Okay, so what don't you know how to do? That's what we need to address.
Okay, no, that one makes perfect sense. I think it was a bit scary when I saw it.
Alright, so yeah, okay, let's get rid of all the messy stuff. Okay. Alright, so that's that one done. Let's look at another question. Okay, so obviously number 4, just to come back to the question, that was that final answer that we got after having done all of those steps. Okay, so question 4's answer was option 4. Question 5, let's have a look. Okay, question 5 is a nice question. Why?
I don't know. Don't you just calculate the log on your calculator?
Correct. Okay, question 5 is testing you in terms of, do you know how to operate the scientific calculator that you have? Okay, so do you have a scientific calculator nearby?
Yes, I have one.
Can you try and type that into your calculator and see if you can get the right answer? It's just a matter of using this button. Okay, there should be a button that looks like that or looks like this. I'm not too sure which one, but one of those buttons on the calculator have an option that you can insert X and you can insert Y. So I'm going to insert 3 here, and I'm going to insert that bracket there, and then the calculator is going to give me an answer.
So I'm looking for log Y, log X.
Okay, the question is quite easy to do because all you need to do, if you've only got that log button on your calculator, okay, then you just need to rewrite this thing in a fraction format. Okay, so one of the rules says, okay, when you have log xy, okay, you can then write that as log y over log x. That's one of the log rules. Okay, so if I had something like this, if I had log 2 6, that'll be the same as log 6 over log 2. Okay, so what I'm going to type into the calculator, if I've got your calculator, I'm going to type this. I'm going to type in log. I'm going to type in log, open brackets, 1073 divided by 7, close brackets. Then divide. And then I'm going to type in log 3. That's what I'm going to type in on your calculator. If you do that on your calculator, you should get the right answer. What answer do you get?
So it's log brackets 1073 divided by 7 close brackets divide by log 3 equals 4,58.
Correct.
Yeah, that's right. Yeah.
That's how you use the log function. If you don't have the other button. Okay, so some calculators have that button, then you just have to insert it. Okay, but it doesn't matter if you don't, then just do it that way.
Okay, perfect. That's easy enough.
Just take the 3, which is the base there, and then the answer there in the numerator. So numerator over denominator will give you option 2.
Yes, this is bringing back memories.
Okay, good. Okay, that's question 5.
Okay.
Alright, question 6 is graphs. You're never ever going to have to draw graphs in the exam because it's a multiple choice exam. Okay, so they will give you options like they've given you here. Your job is to interpret and understand what they've drawn because you need to choose the right pictures that represent the information in the question. Okay, so question 6 says, the graphs 1, 2, 3, and 4 below represents the graph of. Okay, so we need to know what equation do we have here for graph 1, what equation here do we have for graph 2, the same for 3 and the same for 4. Right, well looking at this, I like 4 because 4 is an easy equation. Why is 4 easy to write down? Well, what is x always going to be?
Well, x there is going to be minus 5.
Exactly. So there's your first equation. X is minus 5. That's one of the graphs. X minus 5. X equals minus 5.
Okay.
Okay, so do I have an x equals minus 5 here? Let's check. I've got a y equals 5. No, y is not equal to anything here. Graph 4, y is a whole bunch of different numbers. X is minus 5. Okay, so all of these are actually wrong. Okay, this one's wrong, that one's wrong, that one's wrong, that one's wrong. Okay, so question number 6 would be none of the above, but we need to obviously write down the equations for all of them. Okay, so let me write down the equations for all of them. The equation for graph 4 is going to be x equals minus 5. That's the equation for graph 4. Right, then we need to look at the other equations for the other graphs. Okay, so let's start with, okay, let's go backwards. I discussed 4, let's do 3. Okay, so how do I find the equation of a straight line? This is revision, you need this equation. Y equals mx plus c. Okay, the m comes from the y2 minus y1 over x2 minus x1. That's where the m comes from. Okay, so did I have a gradient here? No, I need to work it out. Did I have a y-intercept here? Yes, I did. There's an intercept. So that's easy enough. I already know what the c is. The c is minus 6. I need to get an m. Okay, so how do I get an m? I need to choose 2 points. So I'm going to choose this point. This point would be 0 and minus 6. Then I'm going to choose this point. That point will be minus 2 and 0. Okay, I need 2 points to find the gradient. Okay, so let's put that into my equation. If I'm looking at y2, I'm going to use that as my y2, then this is my y1. Okay, so minus 6 minus 0 over. This will be my x2, this will be my x1, over 0 minus brackets minus 2. Okay, so let's see what the gradient is. Minus 6 minus 0 is minus 6. 0 minus minus 2 is plus 2. So I have minus 3. There's the m. So what is the equation for the third graph? The third graph's equation is y equals minus 3x brackets, well, no need for brackets because we've got the intercept, minus 6. There's the equation for graph number 3. Okay, it's just y equals mx plus c. That's all it is.
Okay.
Okay, so let's write that down. There's the equation for graph 3. Y equals minus 3x minus 6. Okay, minus 3x minus 6 can be written as that. Y plus 3x plus 6 equals 0. Okay, if I just take things to the one side. Okay, so that's the equation for graph 3. Let's go back. Let's look at the next graph. Alright, so here's another graph. Graph number 2. Same story applies. Find the gradient. So y equals mx plus c. Do I have the c? Yes, I do. There's the 2. The c is the y-intercept. Okay, so I already know what that is. I just need the m. Right, so I need points. Okay, there's a half here. Okay, so a half and 0, and then this point is 0 and 2. There's my 2 points. Okay, so let's apply the y2 over, so m equals y2 minus y1, x2 minus x1. Okay, so I'm going to use this as my y2 and my x2. I'm going to use this as my y1, x1. Okay, so what is my y2? y2 is 2. y1 is 0. x2 is 0. x1 is a half. Okay. Right, so what does that give me? Well, let's check. 2 minus 0 is 2 over minus a half. Okay, so 2 divided by minus a half. 2 divided by minus a half is the same as 2 times 2 over 1.
It's 4.
Which is minus 4. Okay, so now I know what the m is. M is minus 4. I can put that into the equation. So the equation for graph 2 is y equals minus 4 plus 2. Minus 4x plus 2. There's the equation. Okay, so let's write that down. Graph 2. Graph 2. There's graph 2. Y equals minus 4x plus 2. If you rearrange and you make this equal to 0, then you get that. Okay, we need another graph. Let's go back. Okay, so graph 1. Straight line again. So y equals mx plus c. M equals y2 minus y1 over x2 minus x1. Right, what am I looking for? Do I have c? Yes, I do. That's the y-intercept. It so happens to be 0.
0.
Okay, so your c will be 0. There is no intercept. Well, there is an intercept, but the intercept is 0. Okay. Then I just need to look at the y2. Okay, so I need a point. Do I have another point? I need another point. Here's another point. Okay, so there's a 1 and there's a 3. Okay, so let's put that into my equation. My y is 1 minus 0 over minus 3 over 0. Negative 1 over 3. Right, so what's the equation for this graph? It's y equals negative 1 over 3x. Plus 0. We don't write plus zeros, so we leave it as 0. Okay, nothing. Right, so there's the equation.
Okay.
Right, so again, let's write it down. Okay, so graph 1's equation. Write down y equals 1 over 3x. If I rearrange, I get y plus 1 over 3x equals 0. Okay, so do any of those things that I've written in red there look like any of the options? No. Okay, and we knew that already because you didn't have x here. Remember, it was x equals minus 5. Okay, for this graph.
Yes.
Okay, we didn't have that for any. So you didn't even have to do all of that, but I did. So you get that. None of the above.
Okay, perfect.
Okay. Normally none of the above shouldn't be the answer, but sometimes it is. Okay, obviously here, if you've got all the equations for all the straight lines, you don't get any of those options. Unless there's an errata or error here. Unless they wanted you to write x here instead of y, but we can't make that assumption. Okay, I'm just doing the question based on what we've got. Okay, so none of the above would be correct.
Okay.
Okay, here's an easy question. What's the focus in question 7?
Find the slope of the straight line.
Yes.
So that's what we've just done.
That's the M. They want you to work out this. That's what they want you to work out.
Okay, that one's easy.
Yes, okay, so it doesn't matter which option, let's say, you've got options here. It doesn't matter which one you make 2 or 1. So I'm just going to make this one 2 and this one 1. Okay, so what will I have? I'll have 10 minus 8 over 5 minus 6. 2 over minus 1, which is minus 2.
And that is option 1. Yes?
Okay, so question 7's answer, negative 2. Got that?
Got it.
Okay. Right. Question 8 isn't too bad. It's just a little bit of simultaneous equations. Okay, when you're solving for two variables, you need to look at P and Q individually and then substitute and solve. Okay, you can either use elimination or you can use substitution. Elimination doesn't always work because you need to have the same number of terms. Here I've got 3, here I've got 4, here I've got 2, here I've got 6. I can't eliminate. Okay, so elimination wouldn't work for a question like this. So what must I do? I need to substitute and solve. Okay, so I need equations to work out the answers. Okay, so I'm going to use simultaneous equations. Okay, question 8. Alright, so I wrote down those two equations. There they. Okay, equation 1 is that. Equation 2 is that. Right, so I need to make P equal something or Q equal something. Okay, it doesn't matter which you do as long as you've got a number that you can substitute. Okay, so I'm just going to take the first equation and I'm going to solve for something. Okay, so I'm going to make this
0.
Copy that there. Alright, I'm going to keep the P's on that side. I'm going to take everything else to the other side. Okay, so, okay, let me do this. Equals minus 2Q plus 9. Okay, then I'm going to divide everything by 3 to get P equals that. Okay, so P is going to equal minus 2 over 3Q plus 3. Okay, wherever I see a P, I'm going to put it in. Okay, so what do? I'm going to put all of that stuff into the P. Okay, so I'm going to copy that. And I'm going to put all of this in my P. Okay, so open brackets. There we go. Okay, let's multiply all of that out. Alright, what's 4 times minus 2? minus 8 over 3q. What's 4 times 3? 12. Okay, with all of that other stuff outside the brackets. Okay, now I can combine things together. Okay, so I've got 8 over 3q here minus 6q. Okay, I need to combine those two things together. Okay, so I'm going to write down over 3. So 6 times 3 is 18 over 3. Okay, common denominator. I've converted this into a lowest common denominator to get a common denominator, okay, of 3, right? Because now I've got the same terms. Okay, can I add now and subtract? Yes, I can. Okay, so what am I going to get? Minus 18 is minus 26. Okay, minus 8 minus 18 is minus 26 over 3q. Do you agree?
Okay, yes.
Okay, plus 12 minus 25 is what? Minus 13. No. Yes, minus 13. Okay, plus 12 minus 25. Or minus 25 plus 12.
Okay.
Let's just check that.
I did. It's correct.
Okay, yeah, it is right. Okay. Alright, and now I need to solve for q. Okay, so, copy that. Take the 13 across. Okay, how do I get q on its own? Well, that's easy. 13, then I just times by 3 over 26. Oh, negative 3 over 26. Okay, it's on that side. Take it to that side. Becomes multiply and divide. Okay, so what does q come out to? Let's check. 13 times minus 3 over 26 gives me negative 1 over 5. 1.5, sorry, not 1 over 5, 1.5. There's your q. How do I get p now?
You just replace q into one of the equations, right?
Exactly. I take that and I put that into there. Okay, so now I copy this thing. Okay, where I have a q, I'm going to put in 1.5. Negative 1.5, close brackets. Okay, so p equals, let's work that out, negative 2 over 3 times negative 1.5 plus 3 gives me 4.
Okay.
Is that an option?
Yes, option 2.
Okay. Alright, so when looking at simultaneous equations, substitution always works. Elimination can be quicker, but you need to check for it. That's the problem with elimination. So I didn't use it here because it might not have worked. Okay, so all I did is I wrote down equation 1, I wrote down equation 2, made the subject of the equation p or q. It doesn't matter which one you work out first. As long as you work out one of them, then you just substitute the other in and you get the answer. Okay, that was question 8, eh? Yes, great.
Let's have a look. I just want to see the calculation. So, it's minus 8 over 3q. Okay.
Happy?
Yeah, I'll go through the recording again.
Okay, perfect.
Okay.
Yeah. If you have questions, just ask. Yeah, I don't mind if you stop me and ask questions.
No, it should be fine.
Okay.
I just had to go through it slowly.
Okay. Alright, so yeah, I'm just solving for a variable, and then I'm substituting that variable in. Okay, so I started with so this was step 1. Okay. That was step 1. And then step 2 was the substitution. And then step 3 was that bit to work out the answer. Okay, so it's working out the p, putting the p into the equation, working out q, and then putting q back into the equation to work out the p. Okay.
Okay, perfect.
Alright, let's have a look at 9. What's the focus here?
Passes through the point. The equation of the... Okay, so they're looking for the equation of the line. Mx.
Correct. Mx plus c is the focus. If the line cuts the y-axis, what does that mean? That means it's 0 and 10. That's the y-intercept, right?
Yes.
Okay, so they've given you the y-intercept. You don't even need to work it out. You've got the c. So what must you work out? The m. Okay, so what is m? y2 minus y1 over x2 minus x1. Right, it doesn't matter which point you make 1 or 2. I'm going to make this 2 and I'm going to make that 1. Okay, so 10 minus 4 over 0 minus 2. 10 minus 4 is 6. 6 over minus 2 is minus 3. What's the gradient for this equation? Minus 3. What's the equation for this question? Option 4. You had the y-intercept. You had the c already. Okay, so all they're testing you here is basic straight lines, y equals mx plus c, and they're asking you to work out the gradient. Interpretation is everything because you need to know what the y-axis represents. It represents the y-intercept, which is 0, 10. Okay, x is 0, y is 10 because it's a graph. Okay, remember a graph has y and x's? Okay, so if it's cutting the line at 10, that's the y-intercept.
Okay.
Okay, happy with 9?
Yes.
Right. 10. Okay, we had a question similar to this before. I need to write down 9 here quickly, and then 10. Okay, that's 9. Question 10. Okay, they're looking at prices again for different items. That's what they're focusing on here in question 10. They say the regular price of a bicycle is 1,340 cents. The current sale price is 980,20. By what percentage was the price reduced? Okay, so that's now and before. Okay, so before, what was the price?
Before the regular price of a bicycle on the current sale, so it's 1,000. Oh, aren't we looking for the before?
No, we're looking for the percentage change.
Changed. Okay, so it's 1,340.
That was the before, and now it's
980,20.
Yeah, so I'm looking for the percentage decrease. Okay, so that's straightforward. How do I work that out? It's simple. It's the change. Okay, so in mathematics they use a triangle to represent the change. Okay, so let me rather write it like this. Change over the start. Okay, what did I start with? Okay, so what was the change? Where's my calculator? Oh, I don't actually need one. I can use Excel. Okay, equals 1300.40. Okay, less 980.20 equals what? That's the change. Okay, so that was the reduction in price. Okay, what did you start with? What was your price, your initial price?
It's 1,340
Correct.
cents.
So I just need to go change over the original price, gives me a percentage. Okay, so there's the reduction in price. Okay, and there's the change. Change over original price times 100 gives me that as a percentage. Okay, so 24,6232% change in price. Okay, reduction in price.
And that is option 1.
Yeah, we'll go back and check which option is it. Yeah, it's option 1. Okay, so that's the reduction in price. Make sense?
That does, yes.
Okay. Question 11. They're looking at demand. They're talking about price elasticity of demand. Okay, these are some equations that you're going to have to study. There's a few. Price elasticity of demand, price elasticity of supply. There's also arc price elasticity of demand. Okay, it's all economics. Okay, they're not testing the theory. You don't need to explain what price elasticity is here. Okay, that would have been covered in the economics module. All we're focusing here is on the mathematics. Okay, so how do we actually work out the price elasticity of demand? Okay, well, it's pretty easy. Okay, it's the P over the P minus the A. Okay, that's the formula. What is the A? A is just the constant from the equation. Okay, so what's the constant from the equation? P, where's the demand function? There's the demand function. P equals 90 minus 2Q. What's the constant?
Is it the 2?
It's the 90.
Or is it the 90?
Okay, the constant is the number without a variable.
Oh, yes, sorry, yes, you're right.
Okay,
sorry, yes,
so
yes,
there's
yes.
the answer.
Okay, yeah.
That's all. Okay, it's just testing you in terms of the formulas. Okay, price elasticity of demand is derived. Okay, you don't have to worry about the derivation of the formulae. Okay, you'll see the textbook is brilliant in terms of giving you all the steps. They give you way too much, okay, because they literally derive this equation. Okay, we don't need to know how did they get the equation. We just need to know what the equation is and what does the equation give us. Okay, this equation gives us the price elasticity of demand. As long as I know what the constant is, the constant was 90, I would be able to find the price elasticity of demand at any level of price. Okay, so it doesn't matter what the P is. I can substitute any P in here. I can substitute 100 in. Okay, and then I'll get an ED. The ED is representing the price elasticity of demand. Okay, it's basically how sensitive are we as consumers to changing prices in the market. Okay, so for example, if food had to become more expensive, are we still going to buy food? Yes. If luxury goods had to become more expensive, we're obviously not going to buy as much. Okay, so luxury goods are more elastic, okay, in terms of the change in demand when price changes versus food, which would be more inelastic. Okay, happy?
Yes.
Okay. Question 12. What did they want here? Same thing.
Okay, yes.
Except they want point price elasticity when P is 15. Okay, so what's the constant here?
Is it the 215?
Yeah, so 15 over 15 minus 215. Okay, let's type that out and write it down. Okay, so all I had to do was point price elasticity of demand, substitute 15 in, get an answer, option 4. Right, so you're inserting the price that was given. They want the specific point price elasticity of demand. So P now has a number, a value. Is that one alright?
Yeah.
Okay. Let's look at question 13. Okay, more simultaneous equations. Except, how many variables do you see here?
Two.
3 variables. You've got P, Q, and R.
R.
Okay, so there's 3 variables, right? Okay, so let's take this through to our workings. Okay. Alright, so they want me to work out P, Q, and R, and then I can probably add them all up if I need to. Okay, but I still need to find what they are first. Okay, so what must I try to do? Well, the objective here, when you have three variables, is to try eliminate one of the three, so you land up with 2. That's the focus. That's the key. Okay, so how can I eliminate one of the variables? Well, if I look at these three equations, do you agree 1 and 2 have 3 variables? That's a problem.
Yes.
Does equation 3 have 3 variables?
No.
No. Okay, so what could I do? I could eliminate the Q or the R. Okay, so I'm going to start with equation 3. Okay, I'm just putting brackets 3 for the equation. Okay, so what am I going to do? I'm going to get something that looks better than what it currently looks like. Okay, which is 2. Okay, 2Q equals 2 plus 2R. Do you agree?
Yes.
Okay, I took the 2R across. Okay, what do I do? Get rid of the 2. So divide everything by 2. 2 divided by 2 is 1. 2 divided by 2 is 1, so R. Okay, so what is Q equal to?
R.
1 plus R. Okay, so wherever I see a Q, which I do in these two equations, so what am I going to do? Ooh, press the wrong button. Sorry, it's going to bring up clip art now. I need to just close that window.
Okay, no, it's fine.
Okay, there we go. Close that. Fine. Right, there we go. That's the right button. Okay, so this needs to be substituted into there. And this needs to be substituted into there. Okay, so let's write down those equations. So, equation 1 is minus P plus Q plus 2R equals 8. Equation 2 is P plus Q plus 2R equals 0. Okay, there's equation 1, there's equation 2. Right, what must I do? Well, do I have Q's in this equation? Yes, I do. There's a Q there. There's a Q there. Right, so what am I going to do? I'm going to substitute 1 plus R into that equation. And I'm going to do the same thing for this one. Because now I know what Q is. Q is also equal to 1 plus R. Right, so now you've got that. Okay, let's simplify. Okay, so if I simplify this, 1, that'll simplify. Okay, get rid of the brackets. Okay, next step. Minus P stays there. What's R plus 2? 3R. Okay, and then plus 1 goes to the left, becomes minus 1. Does that make sense?
Yes.
Okay. Alright, so that's what I've got currently. I need numbers, so another line. Oops. Okay, there we go. Copy that. Get rid of the 8 minus 1, which is 7. Okay. So now I've got an equation there with P and R. Let's carry on with number 2 now. Get rid of the brackets. Okay. Then simplify. 2 plus 1 is 3 again. Plus 1 goes to the left, becomes minus 1. Okay, and there's the equation. Right, so now I have 2 equations, only with P and with R. So can I combine these two together?
Yes.
Yes, I can. Okay, so those 2 equations can be combined to work out the solve for P and R. That's what I'm looking for. Okay, so, I'm going to show you elimination here because I haven't discussed it yet. Okay, so how many p's do I have here? I've got one p here and I've got one p there. How many r's do I have here? I've got one r here. Sorry, not one. I've got three r's here and I've got three r's there. Okay, so do I have the same number of p's and r's? Yes, I do. Okay, so what can I do? I can eliminate. Okay, so elimination works like this. Okay, you write down the equations and then I look at how do I get rid of the r's or the p's. Okay, so do you agree I could add the two equations or I could subtract the two equations? Either or, I'm still going to get the same answer, right? Okay, so I'm going to use elimination. Elimination. Okay, add / subtract. Okay, so let's add. Adding is easier than subtracting. Okay, so if I add, minus p plus p gives me 0p. 3r plus 3r gives me 6r. 7 plus minus 1 gives me 6. Okay, so r equals 1.
So how would you subtract?
How would you subtract? Okay, so let's do the other one. So copy all of this. Okay, if I subtract, then I'm going to have minus p is minus 2p.
Oh, okay. And then it's going to be, okay, so then the r is going to disappear. Okay, I get it.
Okay.
Oh, okay.
7 minus 1 is 8 plus 1. So, so p is 8 divided by minus 2, which is what? 8 divided by minus 2, minus 4. There's p.
Okay.
Okay, so now we've actually got both doing it that way.
Okay.
Alright. Do you have to use elimination? No, you don't. If you like substitution, you can use substitution. Okay, remember, elimination just is quicker. I'm going to do that on the right here. Okay, if I use substitution, okay, what am I going to do? I'm going to make one equation. So I'm going to do this with this equation. P equals minus 1 minus 3r. Okay, so I'm going to substitute that into equation 1.
Okay, and then I can, that's fine, that I understand.
Okay, that's substitution. Let's put that in. So, minus, brackets, minus 1, minus 3r, close brackets, plus 3r, equals 7. Okay, minus times a minus is a 1. Minus times a minus is a plus. Plus equals 7. Okay, what do I get here? Ooh, 6, eh? Yeah. 6r
is equal to 6.
Yeah, so what is r?
R is 1.
Was r 1?
Yes, it was.
Yeah, so it doesn't matter what you do. Whichever method's easier for you, just do something that works, that you can get the answer, and then do the same thing here. Put the r into that. Okay, so r is a 1. So minus 1 minus 3 is minus 4. P is minus 4, right? Did we get that? Yeah, same thing.
Okay.
Okay, so now do you have P? Yes. Do you have R? Yes. Do you have Q?
No, I don't
So
know.
what do you do?
No.
Go back and find an equation with Q. Ah, there's one. There's an equation with Q. Okay, so what is Q going to be?
So it's going to be 1 plus, and we've got R as 1, so Q is going to be 2.
What is R? R is 1. Yeah, R is 1. So Q equals 1 plus 1, which is 2. Okay, what did the question ask for?
It asked the sum of the values of P, Q, and R. So we have R is 1, P is minus 4, and Q is 2. So minus 1.
Gives you that, right?
Minus 1. Yeah.
Okay, option?
Yeah, it is option 2.
There we go. Okay, minus 1. Alright, so that's simultaneous equations.
Okay.
14, you've done economics, so you'll probably be fine with questions like this.
Yes.
What's the question asking you for?
Calculate the equilibrium price and quantity.
How do I get equilibrium?
Demand equals supply.
Exactly. Okay, so demand equals supply. So I'm going to have 35 minus 0.1p equal to minus 10 plus 0.2p. Demand equals supply. What are you solving for? P. Once I've solved for P, can I get Q? Yes, I can substitute. Do you agree?
Yep.
Okay. Let's see how good your arithmetic is. Do you want to try this one?
Okay, let me quickly do it.
Okay, try work out P and Q. You know how to do it. Demand equals supply, so we're just substituting in and we're solving.
I just want to just give me a second. I'm just going to put a light on.
Yeah, no problem.
Okay.
See if you can get it.
Let's see.
Nice. P is correct.
And then Q will be 3.1. So it's Q equal to 20.
Yes, well done. Good.
Oh, did I get it? Okay, wonderful.
Okay, so yeah, that's it. Okay, so just to show the working, number 14. Yep, P 150, Q 20, that's the answer.
Okay, wonderful. And that is option 3.
P 150, Q, yeah, 3. Okay. Right, question 15. What's the focus here?
Cost and runs manufacturing X bicycle is how many bicycles have been manufactured if the cost is 30,000. So we need to determine how many bicycles were manufactured.
Okay, yes, alright. So again, it's a word sum, right? Okay, where you've got an equation that's representing the cost. Okay, they want to know how many bicycles have been manufactured if the cost is 30,000. So what is the 30,000 representing, your X or your Y?
How many bicycles have been manufactured if the cost is 30,000? We're trying to determine, it's your X.
You're trying to determine X. Yeah, you've got Y.
Okay.
Okay, there's the equation. What's X then?
Okay. It's gonna be 9. No, I've done something wrong.
What's X?
2.4. I get 9.5. What am I doing wrong?
No, you should be getting 122.
Oh, no, it's my writing. Sorry. Let me. 240x equals minus 3,000 plus 720. 3,000.
Remember, you take the 720 to the left, and then it becomes minus.
Okay, I've just done it the other way around.
Doesn't matter which way you take it, it'll just,
yeah.
the sign will change then.
Okay.
Got that?
Give me a minute. Okay, it would help if I'd written down 30,000 and not 3,000.
Okay, yeah, be careful when you just type in the figures, yeah.
Okay, so yes, I've got it.
Alright, so yeah, it's just a simple equation, just substituting in the numbers and then solving for the actual number of bicycles. Okay, so obviously 122 bicycles would have to have been manufactured to incur a cost of 30,000. Makes sense?
Okay. Yes.
Great.